In this video, I'll be going through the question you see on the screen here from the 2025 Leaving Cert Ordinary Level Maths Paper 2. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts of the video when you need to. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. In question 7, we're going to do a tree diagram for a probability. The story they tell us is about someone who's playing tennis, and the chances of them winning their first match they play is, they tell us it here, 0.6. They tell us in writing as well. And the chances of them winning their second match is 0.7. And they tell us it's independent. That's all they had to tell us. They did give us some more numbers here, and they want us to fill them all in. I like these questions because, one, I think they're a really useful way to teach and think about multiple events happening. And you get some genuinely interesting results out. Not so much in this case, but you do sometimes. Okay, can we fill all these? They've left boxes. I haven't bothered with the boxes. Save some ink. Can we fill everything in? If the chances of winning are 0.6, that's 60%. The chances of losing are 0.4, that's 40%. So that's one we can fill in. Again, if the chances of winning are 0.7, chances of losing are 0.3. The chances of winning, they said the second match, the chances of winning, they already told us this, they just didn't write it in, 0.7. They helped us by telling us the 0.3 here though. But again, it's just identical to this. They told us the second match, they will win 0.7%. of the time. They will, or sorry, 0.7 probability of the probability of them winning is 0.7, or they will win 70% of the time. Okay, the next thing to do is to put these numbers together. Down here, we're going to write the probability of both of these things happen. Win-win happening. The probability of win-win happening is 0.6 multiplied by 0.7. And they've done it for us here, 0.42. Put in a calculator, 0.7 multiplied by 0.6 does get that. We do that for all of them. The probability of winning and then losing is 0.6 multiplied by 0.3, and that's 0.18. 0.4 times 0.7 is 0.28. 0.4 times 0.3, they put this one in for us, 0.12. Something to point out here, all of these add up to 1, and they have to, because this is the only thing that can possibly happen. They told us there's no draws, so he has to win-win or win-lose or lose-win or lose-lose, so it has to add up to 1. It's often a good way to test your numbers to check that they add up to 1. Okay, we're going to use this then to find the probability that Sean wins at least one match. Okay, the probability of him winning is this. Well, no, let's do it this way. Which of these does he win at least one match? So this one, he wins one, loses one. So he does win at least one. He loses and then wins. He wins at least one. What about this one? He loses and loses, so he doesn't win at least one. I think some students might have messed up on this one though. He wins at least one. He doesn't win one, he wins two, but two is at least one. So all three of these count. So the answer to this question is 0.42 plus 0.18 plus 0.28. Add them all together and we get 0.88. Another way to have got that is we could have just taken this away from 1, because if this is the only thing that didn't happen, not this is everything else, but that's a little more advanced. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. In part B, they continue with the tennis. Sarah this time is playing tennis, and when she plays a service game, that means when she's serving, The probability that she wins is 0.78. And assume it's independent. The first part then they ask, what's the probability that Sarah will lose the next service game that she plays? Well, if the probability of her winning is this, the probability of her losing, and the answer to B part 1 is just, well, let me write slowly, 1 minus 0.78. Take that away from 1. Do it on your calculator if you have to. It's 0.22 is the answer. Okay, part 2. The probability that the first service game that Sarah loses is the third service game she plays. How do we do that? That's a lot harder. But it's not too hard if you know, but if you don't know, it's very hard. Okay, so what they're saying is that she wins her first game. They're then saying she wins her second game. And then she loses her third. That's the only way that, how do they say it? The first service game that she loses will be the third one. The only way for the first one to lose, it being the third, is if you win the first 2. So to write this in maths, the chances of this happening is 0.78. The chances of this happening is 0.78. Chances of this happening is 0.22. The chances of all 3 of them happening, you have to multiply them all together. If we multiply all of these together, we get 0.1338848, and they asked for the probability to 3 decimal places. So this number is the important one. Look at the next one. It's closer to 40 than 30, so we'll round up 134. That's the probability. Be careful here. Well, you're not going to lose marks actually. They ask for probability. Probability looks like this. Percentage is when we multiply by 100. So if you had to turn this into percentage and then got 3 decimal places, you would have gone all the way down to here, which would have been more than you needed, but it would have been fine. You gotta love these long questions, because part C, we're jumping away from probability onto volumes. I guess they're sticking with sport. They're telling us a child's football has a diameter of 18, spherical, so it's round. The diameter is from here to here. This is 18. Nobody cares about diameter. The only one that, I guess in real life we care about diameter, but in maths we want radius. They're always saying diameter just to make us figure it out. We want the radius. The radius is half of this. It's 9. And they want us to figure out the volume of a ball. We have a formula for that. We can look it up if you don't remember it. I happen to remember it. The volume is 4/3 pi r cubed. 4 we know, 3 we know, pi we know, or we now know is 9. So we can just fill all this in. 4 divided by 3 multiplied by pi, 9 to the power of 3. You can put all that into your calculator and you'll get the wrong answer. I'll tell you why in a moment. If you put all that into your calculator, you would get 3053.6. You'll lose a mark for that. If you put it into my calculator, and probably yours, my calculator doesn't actually give me this until I press an extra button. It first of all gives me 972 pi. This is the correct answer because they asked for pi in terms of pi. There's 2 ways you can do this. You could do it on my calculator and probably many of yours. The other way is you could have just ignored pi here. You could have put in your calculator 4/3 multiplied by 9 to the power of 3. You would have got this number and then leave pi alone. The next part we're going to use pi. We're going to put it in. Very often we don't. It's a lot easier to write this than that. That's the only reason. This is the answer to C part 1. For part 2, they tell us this was a child's football. We're going to use an adult's football, which presumably is a little bigger. They tell us it's the same formula. They ask about the volume, except this time they tell us the answer. It's 5424.6. That's the volume, but it's still equal to 4/3 pi r cubed. This time we just don't know r. But that's okay, we have a formula. It's only one thing we don't know. We can just move things around until r is on its own. So let's start doing that. First thing, I like to get rid of this bottom row, 3. Let's multiply the other side by 3. 3 times this. Have I done all this out? I haven't. Good. 3 times 24.6. You don't have to do this now. You can leave it written like this and sort it out later. Or you can put it in the calculator now. Is equal 4 pi r cubed. Let's see, next thing, let's bring the 4 over. And you can do all this in one go if you want. You can, if you're a little faster. 3 over 4 times 5424.6. I'll just call this 5,000 from now on. Is equal to pi r cubed. And move the pi over. I'll do that in one step. Pi can come over here with the 4. It's multiplying this side, it's now dividing. We're left with r to the power of 3. The next thing to do is to get rid of this 3. That's a little harder. How do we get rid of a cube? We take a cube root. Both sides, let's write it one more time down here, times 5,000. We take all of this to the power of 1 over 3. And this side we take to the power of 1 over 3. That destroys itself and leaves just r on its own. You can now put all of this into your calculator and you will get, let's see, you'll get r is equal 10.8999. That's what's going on. They wanted one decimal place. So we're looking at this 8. Look at the next number. It's closer to 90 than 80. So we'll go up 10.9. And that's your answer there. One thing I'll say about this is it's often very useful to check if your answer makes sense. A child's football had a radius of 9. The adult's football has a radius of 10.9. Slightly bigger. That makes sense. If your answer here was 50, think of it in the real world. This was 9 centimeters. This is 10 centimeters. That would make a football, so twice this for a football. I guess diameter is useful. Child's football is about here. An adult's football is about here. If you got the number 50 for a radius, that means a football would be a meter long. Wouldn't make sense. So always check your answer for, when it's real world stuff, check your answer makes sense. In part D, they gave us a table with percentages and numbers, and they told us this is the number of shots, this is the probability of resulting in a goal. But I think a lot of students might be confused what they're talking about here. So let me try and help you by making up a little extra bit. What this here is, this is how many shots a team took outside the box from a long way away. And this number then is the probability that that would be a goal. So if you took a shot from a long way, say outside the box, there's only a 10% chance that would be a goal. If you took a shot from the edge of the box, right at the corner of the box, there's a 20% chance of a goal. If you took a shot inside the box, there's a 40% chance. And if you took a shot inside the 6-yard line, very close, there's a 70% chance of scoring. That's what they're talking about here. And with these numbers, we can find the expected value. This is also a very useful thing to do. You can do this in lots of parts of life to work out what you expect to get from something. Maybe lots of things, but if you ever want to be a gambler, for example, you better learn how to do this. You need to know what you expect to get, and then you can see what actually happens and adjust your model accordingly. So the expected result here of these 6 shots is each shot I expect 10% of them to go in. So that's 6 multiplied by 10%. I would get 0.6. That's 6 multiplied by, let me write that a bit slower. 6 multiplied by 0.1. That's 10%. I would expect from these 6 shots to get 0.6 of a goal, which means maybe I wouldn't expect a goal from these, but sometimes it would happen. And these 5 shots, 5 multiplied by 0.2 will come out as 1. I expect 1 goal to happen from these shots. These 3 shots inside the box, 3 multiplied by 0.4, I'll get 1.2. I expect a goal to happen from these 3 shots. More than a goal, in fact. And this 1 shot, very close in, I don't expect a goal, but I expect a goal a lot of the times. My total expectation, because all of this happened, we add all this together and we get, just add it all together on a calculator. You would get, let's see, 1, 1.6, 2.6, 2.8, 3.5. This all adds up to 3.5. If you told me a team had these stats but didn't tell me the goals, and you knew these probabilities, I would expect 3.5 goals. That doesn't mean it would happen. Maybe they scored 1 goal, maybe they scored 7 goals, but I would expect 3.5 goals. And if these numbers were all got bigger and bigger over a whole season, I'd be right. In a small sample set though, it might happen, might not. Okay, that's it for question 7. If you have any questions about anything there or any mistakes I made, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day.